Students, now you must have understood that air is everywhere around us.
Air is invisible, untouchable, and tasteless.
Students, let us talk about the properties of air. Look here. This is an empty balloon. Let us blow it. What do you see?
The balloon gets bigger.
Yes, the balloon gets bigger. Have you ever wondered why a balloon gets bigger when we blow it? Well, let me tell you. There was nothing inside the balloon in the beginning. Or the balloon was empty in the beginning. But when we blew in it, the air got inside the balloon. Or the air filled the empty space inside the balloon. So the balloon got bigger.
Yes, the air fills space inside the balloon. So the balloon gets bigger when we blow air into it.
Students, let us take a deflated ball. Now, let's fill it with air. Like a balloon, the ball also gets bigger.
The ball is not deflated now. It has a round shape now. This is because the air fills space and also gives a shape.
So, we can say that the air fills space and gives shape to things.
Or we can say that air has a property to fill space and to give shape to things.
Students, you all like to ride cycles, don't you? Now, look at this flat tube of a cycle. Let us put some air inside the tube. What do you see?
The tube gets bigger. The air fills the space inside the tube and also gives a shape to it.
So, we can say that the air filled the space and gave shape to things. Students, now we know that air fills space and also gives shape to things. Now, let me further tell you more about air. Let us take two balloons of the same kind. Let us blow these balloons to equal size.
Now, let us hang these balloons at the two ends of this stick. You can see that the stick balance is straight.
The stick balance is straight because both the balloons have the same weight. Now let us remove the air from this balloon. Now what do you see?
The balance is not straight. The stick leans towards the air-filled balloon.
It means that the air-filled balloon is heavier than the empty balloon. What do you understand from this experiment?
We understand that the air has weight.
Yes, you are right. The air also has weight. Students, we have learned that air fills space, it gives shape to things, and it has weight. Since air occupies space and has weight, air is matter.
So, air is a matter in the form of gas.
Let me further tell you more about air. Look at this football. The football has no air in it. That means it is deflated. Let us put some air into it with the help of this pump. Now let us press it. What happens?
You see that the ball could not be pressed easily to deform it.
Okay, let us put more air into it and press it again. What happens now?
It is very hard to deform the ball now.
More air in the ball makes it difficult to press and deform it. That means the air inside the ball also pushes outward and makes it difficult to press.
The air inside the ball pushes outward. This means the air inside the ball exerts pressure.
So, air also exerts pressure. Now tell me, when you ride a bicycle in a windy day, which direction do you feel easier to drive?
You feel easier to drive along the direction of wind, don't you?
Yes, it is easier to move in the direction of the wind. Do you know why?
It is because the moving air has force in it. The force of the moving air makes you easier to move along its direction.
You may have seen that moving air or wind blowing papers or leaves. It is also due to the force of the moving air. Now let me show you another example. This glass is full of water. Let us cover this glass with cardboard. Now let us turn the glass upside down.
The paper and the water do not fall. It is interesting. Do you know how this happens?
The air in the atmosphere pushes the paper up, or the air exerts pressure upwards on the paper. And the paper and the water do not fall due to this upward pressure.
So, air can exert pressure, and a moving air can exert force too.
Students, you may also have drunk juice through a straw, haven't you? Tell me how you drink the juice through a straw.
You suck the air through the straw to get the juice into your mouth, don't you?
When you suck the air of the straw, air pressure inside the straw decreases. That means a partial vacuum is created in the straw. We know that if there is a partial vacuum, matter tries to fill up the vacuum. So the juice from the glass moves in the straw to fill up the vacuum. If you keep on sucking further, more vacuum will be created in the straw, and the juice also moves further up in the straw to fill up the vacuum.
And finally, the juice reaches to your mouth. So, by creating low pressure or a partial vacuum in the straw, we can drink juice through a straw.
Students, now look at this fountain pen. Let us press the rubber pouch of this pen. When you press the rubber pouch, you push out the air from the rubber.
Look, the air bubbles are coming out of the ink pot.
When the air inside the rubber pouch goes out, the rubber pouch shrinks. When you release your fingers from the rubber pouch tries to gain its original shape. But there is not enough air inside the rubber pouch, so the low pressure or partial vacuum will be created inside the rubber pouch. Now we know that if there is a partial vacuum, matter tries to fill up the vacuum. So the ink from the ink pot moves upward to fill up the vacuum.
And finally, the ink fills the space inside the rubber pouch. So, by creating low pressure or a partial vacuum in the rubber pouch, we can feel ink in the rubber pouch of a fountain pen.
Students, you may know that we use a lift pump to draw underground water. The lift pump is also called the hand pump.
A hand pump has a handle, cylinder, and a pipe attached to it at its lower end. Inside the cylinder, there are two check valves, an O-ring, and a piston. The handle is attached to the piston through a piston rod. At the upper side of the cylinder, there is water outlet.
At the lower end of the piston, an O-shaped rubber ring or O-ring is attached. The O-shaped rubber ring or O-ring does not allow air and water to pass through it. The upper check valve is at the middle of the O-ring, and the lower check valve is attached to the lower end of the cylinder.
A check valve is a device that allows the flow of liquid only in one particular direction.
When we press down the handle of the pump, the piston along with the O-ring and the upper check valve move up. When the piston moves up, the air pressure below the piston decreases or a partial vacuum is created.
Please note that the air and the water above the upper check valve cannot pass through the O-ring and the upper check valve. Because
the partial vacuum, the lower check valve opens. Then, to fill up the partial vacuum, the water in the pipe rises up to enter the cylinder.
That means the underground water is drawn up in the cylinder.
Now, when we lift the handle up, the piston along with the O-ring and the upper check valve moves down. When the piston moves down, the water below the piston pushes up the upper check valve so that it opens. And at the same time, the water pushes down the lower check valve so that it closes.
When the lower check valve is closed, the water cannot go down to the pipe. It can only go up through the opened upper check valve. So, the water gets collected in the cylinder above the piston.
Now, again, when we press down the handle of the pump, the piston along with the O-ring and the upper check valve moves up. This time, because of the water above the piston, the check valve closes, so the water above the piston cannot go down.
As the piston along with the O-ring and the upper check valve moves up, the water also moves up and exits through the outlet.
At the same time, the air pressure below the piston decreases or a partial vacuum is created. When we continuously lift up and down the handle, we can get a continuous flow of water through the outlet of the cylinder.
So, by creating a low pressure or a partial vacuum, we can draw underground water using a hand pump.